The invited speaker for today is Peter Crawley from the European Commission. So Peter graduated as an engineer, and he has been working within a variety of international research and innovation environments. He joined the European Commission in 1999, where he has worked with the marine environment, industries, and waterborne transport. Together with programming waterborne priorities within Horizon 2020 and the previous FP7 framework, Peter, he led the Commission activities underpinning the launch of a new zero-emission waterborne transport research and innovation partnership with several industries. The Bonus Baltic Sea joint undertaking with several member states, and the DG RTD's contribution towards a European marine and maritime policy. First of all, welcome, Peter, and thank you again for participating to this webinar. Actually, before giving you the word, just a quick reminder. After his presentation, there will be the space for answering some questions for the participants. So please place your questions where I indicated before. Peter, the floor is yours now. Thank you.
Thank you very much, and I'm really pleased to be here this afternoon and for you to have invited me. Actually, I drafted the topic which these two projects have arisen from, so it's really nice to see the follow-up and the impacts on this important work. So I'd just like to give you a little bit of context and sort of thinking behind the proposal for a topic covering the area of these projects. So next slide. So of course the rationale behind new sustainable power sources for waterborne transport is to address climate change, which is an accelerating challenge, and there are greater and greater commitments as we can see the reality of this change. So next slide, please. So there's a high level of ambition. Of course, there is the UN climate change agreement to limit increases to 1.5, well, ideally to 1.5 degrees or well below 2 degrees. The EU has its long-term emission reduction strategy, which, if you look at it, is also covering waterborne transport and the range of potential solutions that are addressed there. There is the European Green Deal, which sets a high level of ambition for the world to become the first climate neutral continent by 2050. We have an intermediate target to become 55% less greenhouse gas emissions by 2030, which is not very long if you think in the lifetime of a ship, and to do this while ensuring growth and that nobody is left behind in this transition. And further, I'd point you to the fairly recently published Sustainable and Smart Mobility strategy, which is also addressing waterborne transport, for example, expecting the first zero-emission ships to be on the market by 2030. You could argue that battery ferries that are out there now are already zero emission. So now we're going to look at batteries for waterborne. So next slide, please. And electric ships. Next. So shipping has had 150 years of evolution of power sources through sail, through steam, through diesel, and now to electricity. Each of these have had a breakthrough. If you compare, and after this breakthrough, it has taken off, and perhaps we're just below that point for electricity. If you take an electric car, it's quite different from a ship. Much smaller, 30 kilowatts, 200 kilograms of batteries, maybe charging 20 kilowatts. Next click. But ships are very different. As you can see, they're much larger. Next. They have much bigger batteries. This picture is the E-Ferry LN, which was a successful Horizon 2020 project. So the figures are in comparison to that. And I think the car is a Nissan Leaf, roughly. Next, so ship batteries are 250 times more powerful, more than 400 times heavier. There's 50 tons of batteries on the LN. Next slide. Charging power is 200 times more. The LN has charging power in the megawatts region, and that's quite typical for battery electric ships. And of course, they need to be safe, particularly since batteries are within confined spaces on ship, which is inherently a confined space. The consequences of fire are serious, and we need certification, which can be slow and quite heavy. Also, there are many more charging cycles. The lifetime of a marine battery is very large, and consequently, the lifetime cost is key for the deployment of batteries in the waterborne sector. It's already commercial to deploy battery hybrids. So this is ICEs that are using batteries for peak shaving. Though those sort of applications are already paying back quickly, but for fully battery electric ships, those are not yet fully commercial. Though the costs from projects like E-Ferry show that actually their running costs are much lower. So even when you're taking the higher battery costs, the higher capex into account, these things are paying back. But pretty well all of the battery shipping that is deployed at the moment, 100% battery shipping, is deployed with some sort of public subsidy. So next slide. So critical for achieving a larger rollout of batteries in the waterborne sector is to cut its cost, because if we can cut the cost, it'll become suitable for many more applications, both for power optimization, cutting the amount of installed combustion engine onboard power, and also for pure battery electric shipping. And this is the thinking behind this topic. It recognizes that batteries for waterborne are different to other applications. They're not like cars. For one thing, they're exponentially more expensive than a car battery. And the power density is not so important. Generally, you have more space and ships can carry large weight. Usually, it's not critical. They need to be safe, of course. They need to be tailored to the needs of waterborne, and it is an area where Europe is leading. Europe leads in battery electric shipping, particularly in Scandinavia. You're starting to see China and some other competitors launch their first battery demonstrators. So we should be careful, and it's very important to maintain this lead to reinforce Europe's competitiveness within a global market that is really accelerating. You're seeing more and more urban battery ferries. You're seeing more and more applications of battery or energy as an energy storage system on hybrid diesel electric powertrains. And going into the future, you're going to see more combined energy systems on board ships, and the days of a direct combustion engine and shaft drive are likely to go. You're likely to see more electric propulsion systems and balancing a whole range of different energy sources to greatly improve efficiency and to maximize the use of zero emission solutions. So this is the context, and this was the challenge that was put to the two projects that we'll present today. So I'm really looking forward to hearing what they are going to do, and if anybody has any questions on this, I'm quite happy to answer. So last slide, and thank you.
Thank you, Peter. So actually, I can see there are two questions we would like to ask you. The first one would be, as we mentioned at the beginning, those two projects that will be presented in the next presentation, they have been financed under this call that you have been presenting so far. And so one of the question would be if you could give some explanation of what the European Commission could consider as good results for those two projects, assuming that they will be successful.
Good results is in the title of the topic. Good results is solutions which are going to substantially reduce the cost of deploying batteries in the waterborne transport sector, which will lead to the increase of take-up of batteries in the waterborne transport sector. So if these two projects and the outcomes from it are leading to greater use of zero-emission propulsion through batteries, that's a good result.
Thank you. And then, if I can, there is one more. So, as we mentioned, those two projects have been financed under the Horizon 2020 framework, and from this year there is this new framework called Horizon Europe.
Sure.
So, one of the questions would be if the European Commission is willing to continue this challenge proposed in this call, also in the Horizon Europe.
Well, I would say yes, and even more so. In fact, within Horizon Europe, in the waterborne side and in the other parts of what we call Cluster 5, which is not very friendly title, it is energy, climate and transport. There is a new partnership addressing batteries and battery development, and the waterborne sector is engaged in that. And there will be topics linked to waterborne batteries there. In the waterborne side, we've launched a new zero-emission waterborne transport partnership, which is very much focused, well, it is 100% focused on reducing the environmental impact from waterborne transports. Decarbonisation, which is a much greater thing than in the past, where we focus really on pollution reduction, but now decarbonisation is much stronger. In the first calls, we have a topic, for example, on, we have two topics. I think we have one on innovative onboard energy storage, which is open to a whole range of different energy storage systems. And we have a topic on a hyper-powered battery ship charging system, reflecting that actually quite a challenge also for these very big batteries is charging them quickly and turning around the vessel quickly, as well as all the connections that link to that. So certainly, yes, we will continue.
Thank you, Peter, again for answering those questions and for joining this webinar.